A sleek American fighter, its props spinning silently. German engineers step up, expecting the familiar, but opening its engine cowling, they find something almost alien. A radial engine, massive, complex, humming with power. And they realize, we cannot duplicate this. This one machine holds a secret advantage. A secret we may never catch up to. Today, we trace the story of how the Germans captured one of the Allies' most formidable fighters, dissected its heart, and discovered that the beating core of this machine was simply beyond their reach. By mid-World War II, the aerial war over Europe had become a ruthless contest of speed, altitude, armor, firepower, and mechanical endurance. The Americans fielded fighters that could escort bombers deep over Germany. The Germans watched, calculated, captured what they could, and tried desperately to reverse engineer the gear of their adversaries. Enter the Republic P-47 Thunderbolt, nicknamed the Jug. Built by Republic Aviation, it carried a massive power plant. The Pratt and Whitney R-2800 double Wasp radial engine rated around 2,000 horsepower, sometimes even higher depending on the variant. This wasn't just a plane. It was an engine on wings. For the Luftwaffe's engineering corps, the chance to get one intact or near intact was like striking gold. In November 1943, somewhere over occupied Europe, a P-47, damaged, out of fuel, or lost in navigation, made a forced landing on German-held territory. German ground crews scrambled, secured the pilot, and then began what was rapidly becoming standard: take the machine away for evaluation. German test pilots and engineers at the famed Circus Rosarius flight test unit at Rechlin were handed the plane. One veteran remarked, "The cockpit could baffle even an experienced pilot." The German engineers assumed they'd see what they expected: familiar components, known materials. But soon they realized this engine arrangement, the turbo supercharger, the plumbing, the cooling system, it was something else. They removed the cowling and peered into the radial engine. innards, the twin-row 18-cylinder layout looming like a mechanical beast. The Germans had good radial engines themselves, but nothing of this scale and sophistication. The R-2800 double Wasp was no toy. It was a two-row, 18-cylinder, air-cooled radial, designed for high-altitude power, built to take punishment. In the P-47 installation, it sat inside a broad cowling, fed by a turbo supercharger, intercoolers, and complex ducting. The Germans opened the cowling and found massive intake ducts under the engine feeding compressed air into the turbocharger. Exhaust tailpipes collected spent gases and routed them to drive the turbine section of that supercharger. The carburetor intake air circulated through, then into cooler, then into each cylinder bank. They measured tolerances. They traced the metallurgy. They logged the entire plumbing system with clipboards in hand. Many of these circuits were unknown in this exact configuration to German engineers. And as they worked, a disturbing realization dawned. The materials, the machining, the scale, replicating this would require resources Germany simply no longer possessed. Let's pause for a moment and imagine the mindset. German engineers in late 1943, confident, experienced, yet stretched thin by the prolonged war. They had excellent design work, but their supply of high-grade aluminum, high-octane fuel, precision machine parts, and time was dwindling. Now they faced a discovery. This American engine was delivering more than raw horsepower. It had superior altitude performance, a robust installation, and modular design. The P-47 could climb, dive, punch, and survive. One German test pilot later commented after flying a captured P-47, "I did not discover the speed for which the Thunderbolt was renowned, at least not near ground level." The implication: at altitude, it had something the German plane makers simply didn't. Even if they could copy one part, the next depended on resources they couldn't get. The whole system became unreachable. Why did this matter? Because in the skies over Europe, the Allies were gaining momentum. The P-47s were providing close air support, escorting bombers, attacking ground targets with impunity. By capturing and dissecting one, German intelligence hoped to find a way to level the playing field, to build an engine and airframe combination that could retake air superiority. But every measurement they took, every profile they traced, revealed something deeper. The Americans weren't simply ahead in one area, they had assembled a complete system. This realization was devastating, because once you understand that your opponent is not just ahead, but systemically ahead, it changes everything. One German engineer noted that when they opened the supercharger turbine housing, it glowed incandescent at full throttle in combat specimens. They simply lacked the metallurgy to duplicate it. It required alloys and heat treatment cycles that Germany's bomb-damaged industry could no longer manage. As the weeks progressed, the captured P-47, now recoded and repainted with Luftwaffe markings, was flown in test flights. Reports circulated: excellent dive speed, good stability, rapid roll. But below 15,000 feet, performance lagged. The Germans logged this in their reports. But at high altitude, where bomber escort battles were fought, the P-47's supercharger and engine package gave it an edge. The Germans didn't have an equivalent mass-produced fighter capable of matching that kind of integrated performance. The conclusion for them was bitter. Their own engine and airframe programs were either too late, too resource-intensive, or simply obsolete. In war, it is not enough to design a better engine. You must design the ecosystem around it: fuel, metallurgy, manufacturing, maintenance, pilots, doctrine. The Germans found that the Allies had outscaled them. This realization quietly changed priorities. The German focus moved increasingly to jet propulsion, rockets, asymmetric approaches, as they accepted that piston-engine fighters like the P-47 were beyond their grasp. Engineers silently shifted focus. Behind the numbers and the metal, there were real men. Engineers who had trained, built, hoped. Pilots who flew, died, crash-landed. Ground crews who scavenged parts in rubble-filled airfields. One German pilot test-flying the captured P-47 recorded that the cockpit seemed vast and unfamiliar to him. He was used to cramped German designs. The spacious American machine made him feel like a small man in a big ship. Everything was too far away from me. There's a moment of empathy here. The student surpassing the teacher. The Germans once led piston-engine fighter design. But here, they were the students again, forced to learn from the enemy they once confronted. And they were forced to face a harsh truth. Even their captured trophy could not be turned into match equipment. That kind of realization, in wartime, is heavier than any bomb. So what did this one captured P-47, one engine, one airframe, truly mean? It meant that the Allies had not just a powerful fighter, but a system, design, production, doctrine, logistics, all aligned. The Germans' technical examination confirmed it. By opening the cowling, they glimpsed the heart of the Allied aviation machine and found themselves outpaced. It meant that a turning point was quietly reached. Not necessarily a dramatic single battle, but the recognition of a gap that could not be closed under wartime conditions. And it meant that the P-47 Thunderbolt's legacy wasn't just in its kills or its missions. It was in being the machine that made the enemy engineers shake their heads and say, "We cannot replicate this. We cannot match this." That in itself was a kind of victory. When the war ended and the factories quieted, the images of that captured engine remained, a testament not only to engineering, but to the deeper truth that in war sometimes the greatest advantage lies not in a single part, but in the entire chain behind it. Narrator, if you enjoyed this deep dive into aviation history and engineering under pressure, hit the like button, subscribe, and ring the bell for more stories where machines met history and people met challenge. Drop a comment below. If you were a German engineer staring at that engine, what would you have done? Thanks for watching. Until next time, keep looking up.